8.4 and example 6, we are going to learn how to find probability that x is less than a particular value, greater than a particular value, or lies between two values. Example 6, a discrete random variable x has the following probability distribution. And we have x, and we have the probability of x, and we have information that tell us that we have 1, 2, 3, 4, 5, 6, and the probability of 1 is 0.1, there is 0.3, no 0.2, 0.2, 0.3, 0.25, 0.1, and 0.05. Find the probability of x greater than 1 and less than 5. And we have to talk about, it is not a specific area. We are expected to find the probability that our value of x is greater than 1 and less than 5. And of course, 1 itself is not inclusive and 5 is not as well included. So x can be 2, 3, or 4. 5 is not inclusive. Remember, there is no equals to. So the probability of this is going to be, this one is acceptable, 0.2, or plus 0.3, or 4, which is plus 0.25. That means we can have a 2, a 3, or a 4. And anytime we hear about the word or in probability, we just know this is addition. That is part A. And this one, the final answer is 0.5, 0.75. That is the probability that our value of x is between 1 and 5, and the boundary is not included. Part B, we are talking of the probability of a value of x being greater than or equals to 2, less than or equals to 4. And what we can see is that the boundaries themselves are included. The boundaries themselves are included. And this one is just going to be like we have had in part A, because 2 itself, x, 2 is included, 3 is acceptable, and 4 is also acceptable. So the same case, we're going to have 0.2 plus 0.3 plus 0.25, which is 0.75. And the reason why, as much as we can see the boundaries are different here, here we have 1 and here we have 2. Note that the presence of greater than or equals to well comes to within the range. And even for less than or equals to, that means the two boundaries are inclusive while the two boundaries in A are not included. Part C. Part C, we are saying that the probability of x is greater than a 3 and less than a 6. And less than or equals to a 6. This one can only occur when x is a 4. Remember, 3 is not included. A 4, or a 5, or a 6, because within 6, then the boundary, the upper boundary here is inclusive due to the existence of less than or equals to. So that means this is 0.25 plus 0.1 plus 0.05, and all this will give you, all that is supposed to give you 0.35, 0.4. And that is the answer to this particular question. What about part D? Part D, the probability of x being less than or equals to a 3. This one, it's just less than or equals to. So anything less than 3 is acceptable, and even the 3 itself. So we are saying that x can be equals to a 1, a 2, or a 3. And this one takes us to the probabilities. We have 0.1 plus 0.2 plus 0.3, which gives us entirely 0.6. 0.6, and that is just how we can solve that question. Okay.